So what does it mean to be senescent? The first thing is you stop dividing. The cells essentially irreversibly stop dividing. And this turns out to be extremely important to prevent cancer. Think about it. If you have some kind of DNA damage, you could pick up a mutation that could drive that cell to become cancerous. But if you can't divide, you cannot form a tumor. So we know that senescence is a very potent anti-cancer mechanism. The second thing that happens is the cells tend to resist dying. And then the third thing that happens, which we think is the most important, is they develop this slew of secreted molecules outside the cell that are proteins called chemokines, cytokines, proteases, growth factors, prostaglandins, leukotrienes, lipids that are biologically active. And what that means is that even though at any given time, there are very few senescent cells, even in very old people and even in very diseased people, but they have this field effect because they're secreting these molecules and they very dramatically affect neighboring cells. What hope is there for these age-related diseases? And the hope is two classes of new drugs that are being considered by the research community. So one is called Senolytics and the other is called Senolytics. And Senolytics refer to a class of drugs that can dampen down those secreted factors and make them secrete either less or sometimes not at all. In the case of Senolytics, what we know is that you don't need to dampen all of the secretions. You just need to get them down by somewhere between 70 and 80%. These Senolytics do work. The problem is, as soon as you take them away, the cells are still there and they start to secrete again. So we have often, and we still do, favor the idea of senolytics. So these are drugs that are designed to kill senescent cells. And the idea is you don't need to have them at high dose because, again, you don't need to kill every senescent cell. You just need to knock them down by 70 or 80%. And now the question is, which of those age-related diseases are helped by killing off senescent cells in a mouse, in a transgenic mouse? Type 2 diabetes, osteoarthritis, osteoporosis, pulmonary fibrosis, skin problems, etc., etc. It has surprised me, I think it surprised the entire field, how many different diseases have been made less severe. For example, Parkinson's disease or Alzheimer's disease. There are mouse models where the mice develop symptoms of Parkinson's or Alzheimer's disease. You get rid of senescent cells and they have much less severe symptoms. Virtually every tissue that has been looked at has senescent cells that increase with age. And by killing off those senescent cells, those diseases can be either ameliorated or at least postponed in their development, and in some cases, even reversed, which would be amazing if that happened in people. So it's still early days for people, but in mice, we know these drugs work.